This lesson, we will now extend the application of the differentiation to higher order derivatives. This will allow us to understand the application of the first and second derivatives to rates of change as an object moves in a straight line. For an object that moves along a straight line, we will define its position using the position time function, st. Then the instantaneous rate of change of the position time function, which will be the ds over dt, changing position over changing time, will become the velocity time function. And if we differentiate once more, that will become s double prime t, which is second differentiation of the position time function, will be the first differentiation of the velocity time function, which means the changing velocity over changing time, it will become the acceleration time function. Example number 1, given the position time function of an object moving along with a straight line, t is greater than or equal to 0, that means the domain time cannot be negative, where s is in meters, time is in seconds. Part A, we want to find the object's velocity and acceleration at any given time t. So the velocity time function is the first differentiation of the position time function, which is negative 3t squared plus 18t minus 15. And your acceleration time, which will be v prime t, which will be s double prime t, will be negative 6t plus 18. Part B, we want to find the average velocity and average acceleration from time equals to 2 to time equals to 4. This means the average velocity is change in the distance over change in time. So let's substitute 4 into the st function and 2 into the st function to find the position, which is 23 and 1 over 2, which is 11 meters per second. Likewise, the average acceleration will be change in the velocity over changing time. So we are going to substitute t equals to 4 and 2 into the velocity time function to find the value. So once we substitute in, you'll see v at 4 is 9, v at 2 is also 9, which will be 0 meter per second squared. Let's verify our calculation using the graph given. So this cubic function is the st function, and this quadratic function is the vt function. First, let's find the changing distance between t equals to 2, t equals to 4 by doing a secant line by connecting those 2 points, and let's find the rise over run. And you will see the rise is actually 22, and your run is 4 minus 2, which is 2. So our average velocity is 11 meters per second. Similarly, when we want to find the average acceleration, we want to find the change in the velocity. So when t equals to 2 and t equals to 4, those are the 2 points on the velocity time function. And let's draw a secant line. And once again, let's do rise over run to find the slope. As you can see, there's no change in the velocity. Therefore, the slope is 0. That's why our average velocity is 0 meter per second squared. Next, we want to find the time when the object is at rest. At rest means the velocity is 0. That means vt equals 0. So our velocity time function is negative 3t squared plus 18t minus 15. Let's put 0 into the velocity. And that's common factor then, by factor out the negative 3. And factor the trinomial. So we know t equals to 1 or t equals to 5. So that means at the first and the fifth second, the object will be at rest. So let's look at the graph. At t equals to 1 is actually the local minimum, so the object is at rest. At t equals to 5, which is actually at the local maximum, the object is also at rest. For part D, we have to find when does the object move in a positive or negative direction. Then we have to look at the positive and negative sign of the velocity time function. So let's write down the zeros for Vt. T will be 1 or T will be 5. And the actual number line, put the 1 and 5 on the number line. And 1 will be empty dot, 5 will be empty dot, because at those 2 points, the object is not moving, the velocity is 0. And we have to put the endpoint on. So V at 0 will be negative 15, so this is a negative solid dot. Okay, now let's look at the positive negative sign. This will be negative, that's positive, that's negative. So as you can see, the object is moving in the positive direction from time equals to 1 to 5, and the negative direction will be between 0 and 1 and 5 to positive infinity. So just remember, when you write down the intervals, make sure the round brackets for all the zeros, but at t equals to 0, that's a square bracket. Part E, we want to find whether or not the object is moving away or towards the origin at t equals to 2. So first, we have to find the position at t equals to 2, which is 1. Next, we find the velocity at t equals to 2, which is 9. So this means you are on the right-hand side of the origin already. And since your velocity is positive, that means you're moving forward. That means you're moving away from the origin. For part F, we want to find out whether or not the object is speeding up or slowing down. That means we have to find the velocity and acceleration at t equals to 2. So V2 equals to 9, acceleration at t equals to 2 is positive 6. Because velocity is positive and acceleration is positive, that means you are increasing your speed. That's why you are speeding up. Now, let's make a summary about the motion of an object. When your st function times by the vt function, the product is positive, that means you're moving away. When you have a product of a negative, that means you're moving towards the origin. Now, when you are multiplying the velocity function and acceleration function, if the value is positive, means you're speeding up. If the value is negative, that means you're slowing down. Example number 2, the position time function of an object is given again. Example number 2, the position time function of an object is given again. However, this time, we're going to find the interval of the times when the object is moving away or towards the origin, and the interval of times when the object is speeding up or slowing down. So first, let's find our velocity time function by taking the differentiation of the position time function, and make sure you common factor them for later use. And we're going to find the AT function by taking the differentiation of the velocity time function. Same thing again, we're going to common factor it for later use. Now, let's find the interval when the object is moving away or towards the origin. First, let's find the zeros for the distance time function and the velocity time function. As you can see here, when I let the st function to be 0 to find the zeros, this is not factorable. So I actually have to go back to the graph to identify the zeros of the st function. Let's write down those 3 different t values. So the first one is 0.23, next one will be 1.88, and the third one will be 6.88. Next, let's let Vt equal to 0 to find the zeros. So I'll get negative 3, t minus 1, and t minus 5 equals to 0, means t equals to 1 or t equals to 5. Now let's put it on a number line. So the first one is the position time, the second one is the velocity time, the last one will be the product of those two. So now let's put all the zeros on the number line. When we put the zeros on the number line, we have to use an open dot. The reason is, at that point, the value is 0. There's no positive or negative sign. So 0.23, and 1.88 and 6.88. And the velocity time will be at 1 and 5. And we're going to copy down all the zeros onto the red line. When you want to find the positive negative sign on the st function, then you have to use the st function. Substitute the different t values in to see whether it's positive or negative. Similarly, you have to choose the values in between those intervals and substitute into the vt function to see whether it's positive or negative. Now, let's check the endpoint. S at 0 is actually 3, so it's a positive value. S at 0 is 3. And V at 0 is negative 15. Okay, so let's look at the product now. In this region here, 6.88, on the right-hand side, 6.88. This is negative, this is negative. Negative times by negative will become positive. Okay, next region, between 5 and 6.88. So this region here is positive, this region here is negative, so the result will be negative. Next one, next region will be 0.88 and 5. So distance times positive, velocity times positive, so the product will be positive. Next one, this is negative, that's positive, so this is going to be a negative. And the next one, 0.23 to 1, distance times negative, velocity sign is negative, so negative, negative becomes positive. The last one, we have positive in the distance time function, velocity times negative, so positive times by negative is going to be negative. And at t equals 0, the distance time is 3 positive, velocity time is negative, so you multiply those two values out, is negative. So this product is solid dot is negative. Once we get the number line for the product, then we are ready to do the conclusions. So the object is moving away when the product will be positive. So T is element of, you're looking at all the positive region is between here and here and here. And make sure you do not include any zeros, because at the zeros, there is no positive or negative sign. So 0.23 to 1, union 0.88 to 5, union 6.88 to positive infinity. And then let's do towards. Towards is when the interval is actually negative. So including the zeros right here, t equal to 0 here. So t is the element of 0 is the square bracket, including t equal to 0 to 0.23, round bracket, union 1 to 0.88, union 5 to 6.88. Part C, we are finding the intervals of time which the object is speeding up or slowing down. Speeding up or slowing down, we are looking at the velocity time function and the acceleration time function. So once again, we're going to find the zeros first and then put it on the number line. For the velocity time function, we already know the zeros. And let's find the acceleration time function 0. So you get negative 6, t minus 3 equals 0 means t equals 3. And that's the number line again. First one is our VT. Next one is our AT. The last one will be the VT times by AT. Once again, we're going to put all the zeros on the number lines and try to find the positive and negative intervals. So for VT, we have a 0 at 1 and 5. For AT, we have a 0 at 3. So for the product of those two functions, the zeros will be 1 and 3 and 5. As you can see, at those three zeros, it's all empty dots because at zeros, there is no positive and negative sign. Next, let's fill in the positive and negative sign. So that's negative interval, positive interval, and negative interval. Acceleration, this will be a negative interval, and that's a positive interval. And for the product, negative, negative become positive. And this region here will be positive times by negative will become a negative. And this region here will be positive times by positive will be positive. And the last one, negative times by positive will become a negative. Let's figure out the endpoint when t equals 0. V at 0 is negative 15. A at 0 is 18. So positive times by negative, it will be negative. So the product here is negative. Once we have the positive and negative sign of the product between velocity and acceleration, then we can do our conclusion. So when the function is speeding up, it means the interval will be positive. So speeding up, t is element of, just remember to exclude all the zeros. So 1, 2, 3, union, 5 to infinity. Then our slowing down, interval will be t is element of, including t equal to 0 because it is a negative, to 1, round bracket, union, 3 to 5. Example number 3, there is a ball is being hit vertically upward. So the position time function is given as a quadratic function where t is in seconds and s is in meters. Now we need to find the maximum height reached by the ball. So that means we're looking for the local maximum where the first differentiation will be 0. That means the velocity time must be 0. So first, let's find our velocity time function. Next, that the velocity time equals to 0 to find the critical points. So t equals to 3. Next, we have to identify whether or not this critical point is a maximum or minimum. So t equals to 3, we have to use the velocity time function, which is the first differentiation. So on the right-hand side of the 3, this is a negative. On the left-hand side of the 3, this is a positive. That means the original function on the left of the 3 is increasing, on the right of the 3 is decreasing. So we can see this is a local maximum. And we're going to substitute t equals to 3 back to the st function to find out the height, which is 46. Therefore, the maximum height is 46 meters. For part B, we want to find the velocity. That means v is unknown. However, in order to find v, I have to know t. They didn't give us the time, but they give us the position. So we have to use the position time function to find out the time first, and then we're going to substitute that time back into the velocity time function to find the velocity. So first, we know this. S equals to 1, that's find t. Let's subtract 1 on both sides. And common factor out negative 5t. So we know t equals to 0 or t equals to 6. So at this point, we know there are two different times when the ball is 1 meter above the ground. So let's find the velocity. V at 0 will be negative 10 times by 0 plus 30, which is 30 meter per second. Another one will be V at 6, which will be negative 30 meter per second. However, since the question is asking for the velocity when the ball is being caught 1 meter above the ground, so v at 0 means the initial velocity when the ball is being hit. So that's not the time it is being caught. So this will be our answer, negative 30 meter per second. So therefore, the velocity of the ball is negative 30 meter per second when it is caught 1 meter above the ground.